All right, this is section 2.4. This is the last section of our chapter 2, and it deals with the cosine law. And so the cosine law describes the relationship between the cosine of an angle and the lengths of the three sides of any triangle. So notice the equation for the cosine law, no matter how you write it, always has one angle, and it has all three sides. Okay? So deriving it is very similar to what we did for sine. Okay? Slightly different. Okay? And one of the reasons why is when we were making the sine law, we had a sine A and a sine B in our equation. And in this case, we're really only going to worry about the cos of one of our angles. Okay, so I'm going to worry about cos C. Okay, so here's my sides. I'm labeling them. And I drew my altitude. That'd be an H. Okay. Now, one thing here is when we use the cosine, back when we used the sine, we had our opposite, which was H over our hypotenuse. Okay. In this case, if we take the sine C, or cosine of C, we're going to need the adjacent. And that's not even one of the lengths on our diagram. And so what we're going to do is we're just going to take this part of the base. That's going to be our adjacent. That's going to be X. And then the rest of it is going to just be B minus X. Okay? So a couple of relationships. The first relationship we're going to use is cos C. And the adjacent of angle C is X. And the hypotenuse of that small triangle on the left is A. Okay, and I'll just rearrange that. And I'm solving for the X because, as you maybe can tell by looking at our finished cosine laws, there's no X in there, so I'm going to want to eliminate that, so that's why I solved for it, so it'll be easier to get rid of it later. Okay, the other two relationships I'm going to use are the Pythagorean theorems for the triangle on the left. A squared equals H squared plus X squared. Okay, and for the triangle on the right. Okay, and it's actually the one on the right that I'm going to substitute everything else into. So C squared equals H squared plus B minus X squared. Okay, so I'm just going to go back up to this one here, and I'm going to solve it for X squared. Okay, because I'm going to want to get rid of the x's. So I'm solving for the x's so I can get rid of them. The h squares are actually going to get rid of themselves in case you're wondering where they're going to go. So I'm just going to start by multiplying that through. Okay, so b squared minus 2bx plus x squared. Okay. Again, I'm going to want to get rid of both the x and the x squared, so I'm just going to substitute my expressions in for both of them. Okay, so instead of 2bx, I'm going to substitute a cos c in there. Okay, and instead of having negative 2bx, I'm going to have, or sorry, that's the one I just did. And instead of having x squared, I'm going to have a squared minus h squared. Okay, and so we're just about done here. Actually, you'll notice you have a positive h squared and a negative h squared. Okay, and so what you're left with there is c squared equals, I'll just put it in a different order, a squared plus b squared minus 2ab cos c. Okay, and so that's your cosine law. Okay, it can be written in different forms. This is the one you most commonly see. Okay, and you'll just see that you have one side that is unknown. You have the other two sides, and then the angle opposite your unknown side. So basically, you can refer to that as two sides and the angle between them. Okay, and you're looking for the other side, which would be opposite that known angle. Okay, and yeah, you're going to see that rearranged, and you can take a look. Like you can do it with a squared and b squared. Okay, just notice that that whatever side you have on here, that's the angle that you know. Okay. You can also rearrange this. Okay, so say you have c squared equals a squared plus b squared minus 2ab cos c. Okay, you want to solve for the angle. Okay, because you want to use this to find an unknown angle when you know all three sides. So I'll just subtract a squared and b squared from both sides. All right, and then okay, and you can get rid of that negative on the bottom if you want. Okay, and you can just do that by dividing top and bottom by -1. And when you divide the top by -1, it just changes the sign on everything. So instead of having negative a squared, you have positive. Instead of having negative b squared, you have positive. Instead of having positive c squared, you have negative, and that's over 2ab. Okay, and you'll see that there's also rearrangements of that for cos A and cos B. And you can look on page 119 for a summary, just making sure that whatever your unknown, because when you use this, you have all the sides, right? So you could actually use a formula that would allow you to solve for angles A, B, or C. So just make sure that if you're solving for angle C, the C goes here, and then you have the other two here. Okay, it's fairly easy to use, and yeah, a really nice, useful formula.